Welcome to students. Today we'll start a chapter. The name of the chapter is motion. So before going to the chapter, let us start with the previous knowledge, rest and motion. What is rest and what is motion? Now you have read in previous classes that a body is said to be at rest if the body does not change its position with respect to time and surrounding, and body will be in motion if it changes its position with respect to time and surrounding. That means if the body changes its position, then the body will be in motion. If the body does not change its position, the body will be in rest. Okay. Now let's express the rest and motion in graphical term or in graphical way. Just see. Let us draw a graph. This is the point of observation O. The body is at point P, which is at a distance R from point O. Is it clear? The body is at point P. O is the point of reference. That means an observer is standing at the point O. The observer is watching that the point P or the body is at point B, which is lying at a distance R from O. Now, if this P point will be constant, it means this body does not change its position, P remains constant. It means this R also remains constant. At that case, the body will be at rest. If the P point changes here at the point P dash, suppose this is X. So from the point O to the P dash, the distance will be R plus X. At that time, the body is changing its position. So here, the body can be called as in motion. Now consider another case. This distance will not change. The P will be shifted here, again P dash, and this distance remains R. It means initially it has angle this, and next time the angle is this. It means if the angle also changes, the body will be in motion. That means angle changes means body's position changes. Position will change means body will be in motion. Now let us see an example. You are going by a bus. You see the driver is at rest with respect to you, means that you and the driver, the distance between you and the driver remains always constant. That means the driver is at rest with respect to you. But a person watching the driver or the bus standing at the roadside, the person watches that the driver is moving. That means the driver is at rest for one person and the driver is at motion for another person. That's why we can say the rest and motion of a body can be determined by the point of reference. That means by which point the body is watched. For some point of references, the body will be in motion. For some point of references, the body will be in rest. That's why the rest and motion are called relative terms. Rest and motion are called relative terms because for some point of reference the body will be at rest and for another point of reference the body will be at motion. That's why you can say the rest and motion are relative terms. That means there is a relation between rest and motion. Thank you. The next point, let us go to distance and displacement. Distance. So what is a distance? What is the distance? So we can write the path covered by a body. We can say the distance is the path covered by the body. It may be a straight path, it may be a curved path, it may be a zigzag path. But the path covered by the body from one point to another point is called the distance. Clear? It is a scalar quantity. So what is a scalar quantity? Now the quantities which has only magnitude, which have only magnitude, no direction, are called scalar quantities. Then what? Its SI unit is meter and CGS unit centimeter. The SI unit of distance will be meter, the CGS unit of distance is centimeter. Now, the distance covered by a moving body cannot be zero. That means if a body moves, the distance will be covered by the body and the distance cannot be zero. So this is the distance. Let us go to displacement. So what is displacement? It is the shortest path between initial and a final point. That means if we take 2 points, one is initial point, another is final point, and if we can find the shortest path. So how can we find the shortest path? We can find the shortest path by joining the 2 points by a straight line. Clear? So if we can find the shortest path between 2 points, that means from initial point to final point, then that shortest path will be the displacement of a body. Or we can write it is the distance covered by a body in a particular direction. That means if a body moves in a straight line, that means in a particular direction, the distance covered by the body will be equal to the displacement. And it is a scalar quantity, it is a vector quantity. Why? Because it is associated with any certain direction. That's why it is a vector quantity. Its SI unit is meter and CGS unit is centimeter. Same. Distance and displacement are same, but distance is not associated with any sort of direction, but displacement is associated with a certain direction. Clear? Now, next, the displacement of a moving body can be positive, negative or 0. That means body will move but the displacement can be 0. We will see how the displacement of the moving body will be 0. Clear? Okay. Let us solve some numerical problem. A person is standing at point A, moves 2 meters towards east, or we can write 3 meters towards east, then reached at point B, and then moved 4 meters towards north, and moved to point C. We have to find the distance covered by the object or distance covered by the person and the displacement. Now see, the distance covered here equal to 3 plus 4, 7 meter. Because A to B 3 meter, B to C 4 meter, so it will be 7 meter. And displacement, we know displacement is the shortest distance. So how can we find the shortest distance? By joining the initial and final point by a straight line. Initial point was A, final point was C. I have joined the A and C by a straight line. Now see, this is a right angle triangle. This is the right angle. This is the hypotenuse. This is 3 meter base. 4 meter is perpendicular. So hypotenuse will be, displacement will be 3 square plus 4 square. It will be root over. It will be 5 meter. Where 5 meter? Now see here. This is east. This is east. This is north. This is south. So this will be northeast. So 5 meter northeast. So when you have to calculate, you will calculate the displacement. You have to add the direction here. Without direction, the numerical problem will be wrong. Is it clear? Next see another problem. The problem is a car moves in a circular path of radius 7 meter. Find distance and displacement. Number A, after 1 revolution. Number B, after half revolution. Number C, after 1/4 revolution. So this problem we have to solve. Now what we'll do? We'll just do the diagram. Let me erase it. The car is moving in a circular path of radius 7 meter. This is the circular path. This is the center of the circular path. This radius is 7 meter. The car starts from point A. After 1 revolution, the car will reach at A. So after 1 revolution, displacement will be 0. Why? Because the initial point is same as the final point. Now what is the distance? Equal to circumference of circular path. Circumference of path, it will be equal to 2 pi r. It will be 2 into 22/7 into 7, it will be 44 meter. So after one revolution, the car will travel 44 meter distance. Next point, after half revolution. See here, after half revolution, the car will reach here at point B. From here to here, to point B. So after half revolution, second I, after half revolution, displacement will be 14 meter, because this is the radius and this is the diameter. So A to B will be the shortest path, and that will be equal to 14 meter. And here distance will be half to by, distance will be 22 meter. And in 1/4 revolution, distance will be 11 meter, and the body will reach here at point C. Now see here, this is a right angle triangle. A to C join. It will be 7, it will be 7. So it will be 7/2. So displacement equal to 7/2 meter. In which direction? See here. This is north, this is west, northwest. Now the distance is symbolized or written with the symbol S, and displacement is written in the symbol S over arrow. So by reading distance and displacement, I think you can do a differentiation between distance and displacement. I hope everything is clear to you. Thanks everybody for watching. In next class, we'll read the next part of the chapter. Thank you all.